What if you need to factor a trinomial, something with 3 terms, and there is an a value, there's a coefficient of the x squared term, and you can't factor it out, or there is a GCF, but you're still left with some value other than 1 in front of the x squared term. Your first step is to multiply the a and the c value together. Remember, a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So you need to multiply the a and the c value together. That's 5 and 2. And that is going to go on the top of your, on the top of your diamond. 5 times 2 is 10. We're looking for ways to multiply to 10. And then you're still looking for ways to add to the b value. Yeah, so these steps we don't exactly do what's written on here. I apologize, folks. You do start with step number 1. But then I'd say add to the b value, which is 11, and then this goes in diamond. So this is your a times c up here that you're trying to multiply to, and this is your b value there. So now, you do the diamond. You're looking for numbers that multiply to 10 and add to 11. And people kind of panic sometimes when your product or the number that you're trying to multiply to is smaller than what you're adding to. It's not usually that way. But don't panic. Look at your list, folks. These are the ways to multiply to 10. Now, they both could be negative as well, because a negative times a negative is a positive. But that's silly because we're trying to add to a positive 11 here. So it's that pair. Now, a lot of people get excited because, we did the diamond, we solved the diamond, so I put those behind the x's. That is true. That's true. You put the 1 and the 10 there. I switched the order. It doesn't matter. You could have 10 and then 1 or 1 and then 10. But the thing is, this cursed 5 out in front that we had to multiply with c, we now need to bring down and divide these values from the diamond with. And then you simplify. So the first factor, in this case, they typed out, mine are switched, says 10 divided by 5, which is just 2. 10 divided by 5 is 2. So it simplifies to x plus 2. Now, this second one that I'll switch to highlighting in blue, 1 divided by 5, we can't simplify and do not turn it into a decimal. And even if you could simplify it, if you're still left with a number on the bottom, that number on the bottom is going to get drug, as they show here with this fancy arrow, out in front. So it goes to 5x plus 1 for the other factor. Again, if you simplify the fraction and there is no denominator, it's just a 1, there's nothing to drag. You can drag the 1, but that's silly to write that. But if there's a number other than 1 left in the denominator after simplifying, and this one we couldn't even simplify, when there's a number left on the bottom, drag it out in front. And a lot of people love slide and divide. I don't like it because the process is kind of magical in terms of why do we actually slide that thing in front of the x? It works. It always works. This is your answer. Whereas this thing up here is not your answer. If you start foiling that together, folks, you get x squared. You're supposed to get 5x squared. You're supposed to multiply the constants to get 2, and you get 10. There's no way this thing is right. You do get an 11x, but it's all got to be right. When you FOIL this together, you get 5x squared, you get 2, you get 10x, and you get 1x, which makes 11x. That is the perfect factorization. You can't factor it any further. And when you multiply it together, you get the original trinomial. It's truly that original trinomial factored. So I'm going to skip the split the middle technique just for a second because I actually have to go over to the 4-term method in order to do this method. But the method, if you're looking at doing pre-calc, folks, pre-calc, they want you to be able to do this where you just figure out, so if you have a plus and a plus here, you got to have a plus and a plus here. And then you figure out what would multiply here to give you ax squared. If it's just x squared, it's going to be an x and an x. And then what multiplies here to C, which you always do that in your diamond. You're figuring out, all right, how do I multiply? What two numbers should I put in here so when I multiply them together I get C? But then you're going to have to guess and check, like with your smiley face check, to see which one gives you the right BX term. There will only be one pair. Well, two pairs, because you could switch the order. In your diamond, the number on the left and the right don't really matter. So you can switch that. That's kind of where I loosely said there's two pairs, if the order doesn't matter. If you have a positive here, but a negative in front of the B, you're trying to multiply these two constants right here to a positive. But the sum is a negative, so that means both numbers need to be negatives. So then you're, again, guessing and checking what needs to go there and there. And last but not least, if you have a negative here, it means one's positive and one's negative. And the order matters. The number that's negative, when you find like the right two numbers, you need to pick the right negative one and the right positive one. You can't switch those. Otherwise, your sum will be wrong. Kind of like, if you're like, what are you talking about, Mr. P? It's kind of like, where did that go? I erased it. Shoot. It was like right here, where when we did our diamond and we knew it was going to be, 6 and 2, because we were trying to multiply to negative 12 and add to 4. You've got to make this the positive and this the negative. If you switch the positive and negative sign, it would be a negative 4x, and that would be a fib, because that's supposed to be a 4x. All right, so guessing and checking. Those of you doing pre-calc, I'd love to work more with you on that. Split the middlers. Before we can do split the middlers, we need to understand what factor by grouping is, because split the middlers do this all the time. Because while you start with 3 terms, you eventually get 4 terms. So what happens if you have 4 terms? You hug the first 2, you hug the last 2. Within this little hug, you try to pull out a GCF of that. Within the first 2 terms, you can pull out a 2x squared. And you're left with x minus 4. Then you try to pull out a GCF of the second group, or the last 2 terms out of the 4 terms. And in this case, you can pull out a positive 3. Notice what's left inside matches. It needs to. If it doesn't match, you likely need to go back and make sure you truly took out the GCFs. And if this is exactly opposite of this, you're doing a great job. You just need to make this term negative, which then switches these back to match. Whoa. To match the other one. And again, you check your factoring by distributing to make sure you're doing it right. And then comes the last step. This matching binomial is one of your actual factors of the polynomial. Your other factor of the polynomial is these mini GCFs, and you put them together. And then, folks, if you FOIL this, you'll see that you truly get the 4 terms up above. So, with splitting the middle, there's a fly in here. I don't know if you can hear that. That's weird. Let summer begin. Alrighty. So, for the split the middle technique, you still do the AC, A times C process, which is 5 times 2, which is 10. So we're looking for numbers that multiply to 10, add to B, which is 11. Oh, I'm running out of space on this thing. So it's 1 and 10. But here's the change, folks. You got to slip, I guess we're using the variable x here in this problem. You need to slip x's with that. That makes 11x. 1x and 10x is 11x. So we're going to rewrite this polynomial. I'm going to have to grab everything, slide. Ooh, well, not good enough. Well, that's funny. How did that happen? All right. So we're going to rewrite this polynomial, or, here's your original problem. You probably have it written on, like, your paper if you were doing this problem, not just as an example on this chart. So you rewrite this by splitting the middle term. This 11x is going to become 10x, it's a positive 10x, and a positive 1x. And then you bring down in front the 5x squared and the positive 2. I like this method better because I can see that this line that I just wrote is equivalent to the line above it. And with math, we're trying to make things equivalent. Like each step is supposed to be logical and sequential, and we can see the process and you can argue it that, yes, this is right. Now, folks, and by the way, these numbers are really important. It's either 1x and 10x or 10x and 1x. Like, you have to do the diamond correctly. The numbers that I wrote in black, the 10x and the 1x here, if you would have picked a wrong pair of numbers, factor by grouping is not going to even work here typically. You can't go on. We picked the right numbers, trust me, folks. And by the way, if you don't like the way I grouped it, if you want to switch the 10x and the 1x because, like, this one right here scares you, woo, what am I supposed to factor out of this? And I know why you're scared, and that's fine. If you just get scared and you wimp out, just switch the 1x and the 10x around, and maybe you'll like factoring that second parentheses then. You'll still get the right answer. But let's proceed with this one. So I can pull a 5x out of the first one, the first pair. So I'm left with x plus 2. Does that truly equal 5x squared plus 10x when I distribute back in mentally? Yes, it does. And there's nothing else I can factor out of there. What can I factor out of this second one? If you say nothing, you're kind of right. But factoring is a multiplier. So 0 is not like the number that you can factor out for nothing. It'd be a multiplier of 1, which is silly. But then we're left with x plus 2, or 1x plus 2. Really there's 1s in front of each of these. So now, folks, again, we have these matching binomials that are left. And so that actually becomes one of our factors of the actual polynomial. I shouldn't have written that on the border. X plus 2. What's your other one going to be? Group together the 5x and the 1. Your little mini GCFs right there and there. And that's your final answer. If you were to FOIL this together, you would get the original polynomial.